So we're going to look at standard deviation. So we're going to start with, what is it? It is a measure of how data values vary in relation to the mean, and mean is an average. And we represent it using the Greek letter sigma, which is this guy here, and that's standard deviation. When we look at standard deviation, a lot of times we get this image here, which is well known as a bell curve. And so on a bell curve, you have here, this is your average. And then on a bell curve, as you can see down here, right? So here's average. Most of your data, right? So 68.2% of your data lies plus or minus 1 standard deviation away from the mean. And then as you go further away from the mean, there's less data near the average. And so when we're looking at this data, you're looking at how far away from the average are your data points. A lot of times you see bell curves with height, right? So you have, the average height of a high schooler. Most people's height will land plus or minus 1 standard deviation of the average, but then over here we would have some really tall people who are way above average. There's just not very many of those people. And then we have down here, these would be people on the shorter end. Again, not as many as average, but they are part of the curve. When we talk about comparing standard deviations, if you have a pretty small standard deviation, you're going to get a lot of your data is pretty close to that average. Whereas if you have a larger standard deviation, right, from your average, your data is a little bit more spread out away from the average. Where here, you may have the same amount of data points, but generally speaking, they are closer to the average on a small standard deviation than they are on a large standard deviation. So let's take a look at this example here. So these are test scores of 2 of Mr. Perlman's classes. Class A has an average of 88.6%. Class B has an average of 87.3%. Which of the following correctly compares the standard deviation of the scores of each class? Well, Class A, the average was an 88.6. And for Class B, the average is 87.3. And we're not so concerned with what the average is, but we want to see how close to the average are these values. So if I'm looking at Class A, 88.6 is, right around that middle value. But look at, I've got this 68 and I've got this 99. Really even I would say a 98 and that 79. They're pretty far away from an 88.6. Now let's compare that to Class B. The average is an 87.3. So again, average is about middle, but look how far away from that average the data points are. Right? These are all 85s. They're not that far away from an 87.3. And really the furthest on the upper end of Class B, the scores are a 90. So again, really not that far away from the average. So let's look at what our options are. The standard deviation of the scores in Class A are smaller, Class B are smaller, they are equal, or we cannot determine it. We can definitely determine it. So it's either A, B, or C. Well, as we just said, Class B, on average, the data is a lot closer to that average value than in B. Than in A, the 88.6. The data points for Class A are just generally further away from that average, on average, than in Class B. So the statement that would be true here is B. Class B has a smaller standard deviation because the data values are closer to the average, on average, than the data points in Class A. Okay, now let's talk about skewed data. So we've already seen an example of normal distribution, right? You kind of have this even curve. But your data could possibly not be what we call normal. It can be right skewed and it can be left skewed. And one of the things that we want to compare for these are your mean, so the average, and your median. On a normal distribution, your mean and median are going to be about the same. Okay. They're not going to be exactly the same potentially, but they're going to be really, really close to each other. Now, for your data to be skewed towards the right, your median is going to be your middle value. So it's going to go closer to where more of your data is. So for this one, your median is going to be about right here. But then to have it to be skewed, your mean is going to be to the right of that median. Okay, so the average is going to be a larger value than your median. And then left skewed is the opposite, right? Your median of your data is going to kind of follow, again, the majority. So it's going to be over here. But to be skewed left, that mean would have landed to the left of the median. And so one thing, one phrase that might help you here, the mean follows the tail. So if it's skewed to the right, your mean is to the right. If you see the tail, we mean this part of the curve. Versus left skewed, that tail's on the left, the mean is to the left of the median. One quick note on median, you guys can have calculated this for, years really at this point. Median is the middle of the data, but it's when it's ordered least to greatest. So if your data isn't given to you in least to greatest, you need to reorder it first, then calculate the middle value of the data. All right, now let's look at, how do we actually calculate standard deviation and what does it mean? So on your notes page, you're given a formula, which it might look a little intimidating, and even this table might look a little intimidating, but it really isn't bad at all, okay? So let's start talking about this first part here, this X value. These are just your given data points, right? This was the points in your set. Now, in your notes, it shows it this. I just didn't put it in on this slide. This right here, that is your mean of your data, right? It's the average of those, 5 points that we were given. Then in order to evaluate all of this, right, the first part that we can focus on is the difference between your data point and the average. And so that's what this column is. Then we're going to square it. So that's what this column is. We're just kind of piecing it out. From here, what we're going to do is, I write it a little bit differently, but it's the same idea. So this and this, right? Those are just the average of these. All right, so the 38.86 is what you get when you add all those together, right? That's why we have the summation. And then the 7.72 is the average, right, of the difference of the data point and the mean squared. And then to do the standard deviation, you're just taking the square root of that average. So if I do it over here for data set 2, right, the first thing we're going to do is we're going to find the average. So I'm going to take 13.4 plus 11.7 plus 18.3 and so on. And I'm going to divide it by 5, because that's the 5 values that I have. And if I do that, I'll see that I get a 14.5. Okay, so now if I kind of follow the table that I've got, I'm going to do, I'm going to kind of cut out that left-hand column, and I'm going to start with, well, find the data point minus the mean. Okay, so I would start with my 13.4, and I'm going to subtract the 14.5, and then do that all the way down my table. So there's my 5 values, and I'm going to calculate what each of those gave me. Got a negative 1.1, negative 2.8, 3.8, 0.09, 0.04. Okay, now what I'm going to do is I'm going to square those values. And so just grab a calculator. This is positive 1.21, 7.84, 14.44. Oops, hold on. I miscopied my own notes on those last two differences. This would be a 0.3 and a negative 0.2. Okay, now that I have those, what I'm essentially doing is I'm going to take their average. And so add all those together, divide it by 5, we see that I have a 4.724. And so then to calculate the standard deviation, that's going to be the square root of that 4.724. Rounding to the hundredths place is fine. That's approximately a 2.17. So now let's compare these standard deviations. So which data set had a greater standard deviation? Well, that would be set 1. I'm going to abbreviate because I already know I'm going to run out of space on here. Okay, so how would these look differently on a curve? What would look differently is data set 1 would have a wider curve, not by much, but by just a little bit. So for example, set 1, right, we know the average, we found that to be 15, right? So if I go 1 standard deviation in each direction, I'm going to be adding 2.79. So this is going to be 17.79. Extend this. Sorry, my notes are off. And then go the other direction. And then so then I would have my curve here. But then for set 2, right, my average was a 14.5. And so if I go, 1 standard deviation in both directions, I'm going to be adding or subtracting a 2.17. And so what that's going to do is it's going to make it just a little bit skinnier than in set 1. So graphically, that's how they would look different. Okay, now let's go ahead and do this in a graphing calculator. You have the steps right here that are written in your notes for you to reference back to. So I'm going to leave this. I'm going to go to my calculator. And so let's see if I go to stat, edit, and it looks like I already had these in here, 83, 87, 90, 92, and 85. If you already had data in here, just go up to L1 and hit clear, and then you can hit enter and come back and get the rest of these. So from here, we're going to go back to stat, but we're going to go to calculate, and you want the 1 var stats. And you can just hit enter with these. You want to use your L1 list, that's fine. Just keep hitting enter, enter, and calculate. And so you're going to use that sigma x. So we got a 5.97 if I round. So a 5.97. So what does this signify? What that signifies is Andrew's average test score is at 85. So most of the time, Andrew will earn a score of 85 plus or minus 1 standard deviation. And so you can calculate the two of those, or you can even round that 5.97 up to a 6 because we're talking about scores, right? That's going to be the majority of that data point. It's going to be in that middle part of the curve. And that's what a standard deviation is. Okay, use all of this for your homework.